Okay, now I'm going to do some of the application problems. And so you remember that we are doing derivatives again. We've been doing integrals for a while. We're doing derivatives. So the applications are derivatives. So find an equation of the line tangent. We know what that means. Use a graphing utility to graph the function and the tangent line at the point, and use the derivative feature of the graphing utility to confirm your results. Okay, so there's multiple tasks here. You're going to do number 77. This is number 78. So part A, find the equation of the tangent line. Same properties that I've always used for finding the equation of the tangent line. Same steps. Take the derivative. Derivative of 4 is nothing. Derivative of negative x squared is negative 2x. Now I have my new rule. U prime over u. And all I need that for is to find the slope at my point. And on number 78, the point was 0, 4. Number 77, you're going to be using 1, 3. So I'm going to find f prime of 0. So that is 0 minus 1/2 over 0 plus 1, which is a slope of negative 1/2. Equation of a line, y minus 4 equals negative 1/2 x minus 0. So that's part A. Part B, use a graphing utility to graph the function in the tangent line at the point. Alright, so, oh boy, got some logs in there. So the function, making me clear out all my derivatives set up. All this neat stuff. So the original function, 4 minus x squared minus natural log, I'm going to do 0.5x so I don't worry about the fraction, plus 1. So that's the original function. And then your tangent line, you need to move the 4 over, but that's all you got to do. You don't need to solve anything. So negative, it's going to be negative 0.5x plus 4. That'd be my slope-intercept form. Now when I graph this, we should be able to calculate the intersection of my two functions, and I get 0, 4. So if I go to calculate intersection, enter, make a guess. So that's 0, 0, 4. So we verified the function. If you were showing evidence, you would make a sketch of that bizarro function and the tangent and make sure you show they intersect at 4. Okay? Next step of the directions say, use the derivative feature of a graphing utility to confirm your results. You're like, what? Well, this is how you can do it. You go to your calculate derivative and make sure you're on the right function, which we are, and we want to find the derivative at 0 because that was our point. So you enter 0 and it tells you the derivative is negative 1/2, which is what we wanted. Next problem we'll do is number 84. You have to do number 83. Use implicit differentiation. So implicit means we take the derivative like we would, but then everywhere you had a y, you put a dy dx. So we split this up. Natural log x plus natural log of y. Always split up your logs as much as you can. Makes for easier derivatives. Plus 5x equals 30. Now we didn't take any derivatives yet. We just split up the log. Derivative of this, 1 over x, 1 over y, dy dx, plus 5 equals 0. So we're going to move the 5 and the 1 over x over here. And then multiply by y. So I have dy dx equals, negative 5y minus y over x. That's good enough. That's the answer. If you're looking for an answer on a multiple choice question, it might have x as the denominator, so we'd have 5xy minus y. If you want to change, this is another place I talk about this little shortcut for changing the denominator. If you only need to change one, you want to add fractions, you can multiply by x over x. That's where the 5xy comes from. And you can always check, it's good arithmetic here, check there, does it reduce to what you started with? So that is the slope. The problem might keep going and say, find the equation of the tangent line after that, but right now we're not doing that. Next set would be problem number 89. You're going to do that. It says show the function is a solution of a differential equation. So I'm going to do number 90. So here is the function, and this is the differential equation. Differential equation is just fancy. It's got letters, numbers, variables. So all we're going to do is substitute everything in and see if we get a true statement. So I know there's a y prime over here. I'm going to have to put that in. There's a y. I'll put in. So let's find our y prime first. Product rule. U v prime plus v u prime. That's my x ln x derivative minus 4. So my derivative of y is 1 plus ln x minus 4. So negative 3 plus ln x, or 3, whatever, if you ln x minus 3. Now I'm just going to substitute. X stays x. Y is this mess. X ln x minus 4x.